find the smallest of 3 consecutive integers such that when 5 times the largest is subtracted from the square of the middle one, the result exceeds 3 times the smallest by 7. And to start a problem like this, we just need to make some variables. We can start with the smallest integer, which we'll call s. So that's for the smallest. And then the middle one, we can call m, is just the smallest integer plus 1, since these are all consecutive or in a row. And the largest integer we'll call L, and that's just s plus 2. And now looking at this next part here, that when 5 times the largest is subtracted from the square of the middle one, the result exceeds 3 times the smallest by 7. So 5 times the largest is subtracted from the square of the middle one. So we can write the middle one, which is s plus 1 squared, and then we're subtracting 5 times the largest. So 5 times this s plus 2, and then the result exceeds 3 times the smallest by 7. So the result, or that this is equal to, 3 times the smallest plus 7, since it's exceeding this result by 7. And now we just have an equation involving s, which we can solve for. So if we expand this square, we can write it as s plus 1 times s plus 1, so that we can FOIL it out. And then distribute in this negative 5 to each of these. We have minus 5s minus 10, and this is equal to 3s plus 7. And now FOILing this out, we have s squared plus 1 times s plus 1 times s, or plus 2s, and then plus 1 times 1, which is just 1, minus 5s minus 10. And I'll put these on the left side of the equation. So essentially we're subtracting 3s and 7 from each side. So we'll have minus 3s minus 7, and that way we can set the equation equal to 0. And now we just need to combine like terms. So there's only one squared term, so we have s squared, and then a plus 2s minus 5s minus 3s. So the negative ones, minus 5s minus 3s, is just minus 8s. And then plus 2s will leave us with minus 6s. And now combining the constant terms, we have a plus 1 minus 10 minus 7. So again, the negatives, minus 10 minus 7 is minus 17, and then plus 1 gives us minus 16, and this is equal to 0. And with this one, you could use the quadratic formula, since it will give you the right answer, but it looks like this factors. So let's try and do that. So we can write this quadratic as 2 sets of binomials multiplied together and equal to 0. We know that the first terms multiply to give us this s squared. So each of these have to be s. And remember, we're just doing the FOIL method in reverse. So we can figure out now what these second terms are in these binomials. We know that this is the last in the FOIL method, so they create this minus 16. So we need to think 2 numbers that multiply together to get minus 16. So the numbers that multiply to get 16 are 2 and 8, 1 and 16, or 4 and 4. And one of these has to have a minus sign on it, so I'm going to put that in front, though it could be on either of the numbers. And our clue to figure out which of these pairs is correct is this minus 6s. We know that it's created from the outer and inner added together. So we need to think which of these numbers can add together to get minus 6. And in our case, the only ones that will work are this 8 and 2. If we had a minus 8 and a positive 2, we would get negative 6. So we can have minus 8 here, and minus 2 there. And if you want, you can check your answer by re-multiplying this out and show that it does indeed equal this s squared minus 6s minus 16. Now that we have it factored, we can easily figure out which s values make this entire expression equal to 0. Since if either set of parentheses is equal to 0, 0 times anything is 0. So if we can put in an s value of negative 2 here and an s value of 8 here, it will make either of these equal to 0, and therefore the whole expression will equal 0. So s is equal to minus 2 and 8. So our answers are either minus 2, minus 1, and 0 for the consecutive integers, or 8, 9, and 10. And you can check that this is true by just plugging in the s value into this equation here. Though on the CLEP test, the question might specify whether or not the integers have to be positive. But for now, since this particular question did not, our final answer is both of these.